This is quiz 27, and we are dealing with Newton's method. And in the first problem, we're supposed to use each of these initial approximations, starting at 0, in other words, starting at 1 or starting at 5, and determine graphically what happens if Newton's method is used for the function that's shown up here. So if we start at 0, let me choose a different color here. So let's just use this kind of lime green. Well, that might be, let me try again, because I just realized that might not be visible. Let's go ahead and use a dark red. Okay, so if I start with 0, Newton's method says follow the tangent line. The tangent line at 0 looks like it would be like this. And we follow that tangent line until it hits the x-axis, and this would be our next approximation, x1. We take that point, go to the y value, and construct a tangent line there. The tangent line at that point is going to look like this. We follow the tangent line, and it's going to take us here. Go up to the curve there, follow the tangent line, it's going to take us back to the x-axis here. All these, if you go in the other direction, you're never going to hit the x-axis. So the place where you hit the x-axis is always to the left, and so if you start with x sub 0 equal to 0, the solutions, or the iterations, the x sub n's, are going to march off to minus infinity, or in particular, they're not going to come to any of the roots of this function. So that's what happens in the first one. The process moves away from any of the roots. Okay, if we're at 1, now I didn't draw this real well, but the point 1, x equal to 1, was intended to fall directly underneath the peak of that curve, so that you follow the tangent line, you will never hit the x-axis. So that's what happens in this case. The process fails. Newton's method fails because your tangent line is horizontal. Okay, and in the third case, x sub 0 equals 5, if you draw the tangent line at 5, following the tangent line takes you to here, and then following the tangent line again takes you, and you're practically right on top of the root. So after only a couple of iterations, it will converge to the root that is located near x equal to 6, and it'll converge very quickly. So of the 3 initial values, only this one was really any good. Okay, so that takes care of problem number 1. Problem 2 is a routine calculation. We're supposed to use Newton's method to obtain 2 approximations where f of x is given to us by a formula. And so the formula is x squared minus 7. And the initial value for Newton's method here was 1. So we need to remember what the formula is, which in English says the next value, x sub n, is the previous value, take away y value at that previous x, divided by the slope at that previous x. Oops, sorry, should be adding minus 1s here all the way along. Previous x's. So the current x is the previous x minus the previous y divided by the previous slope. So we need the slope at every x in order to do this, so let's calculate that. The derivative is just 2x. Okay, so x sub 1 is going to be x sub 0, which is 1, minus f of x sub 0, f of 1, divided by the derivative at 1. Well, this would be 1 minus f of 1 is 1 minus 7. That would be negative 6. And then f prime at 1, well, I messed that up. F prime of x is 2x. So f prime at 1 would be 2 times 1, which is 2. So this is 1 minus minus, makes it 1 plus 6 over 2, which is 3. 1 plus 3 is 4. So our first value, x1, is going to be 4. Okay, then we do it again. So x2 is going to be x1, which we know to be 4, minus f of 4 divided by f prime of 4. This is going to be 4 minus, now f of 4 is 16 minus 9, 16 minus 7, which is 9. And then f prime of 4 means you plug in 4 here, which is 2 times 4 is 8. So 4 minus 9 over 8, which is something like 23 over 8, but this is good enough. And that is it for quiz 27.